So, my name is Jason Pearson, and I'm going to be talking about advanced and practical motion layout. It's a library that you've been seeing amazing, wonderful demos of for the past year. When you first get into it, when you look around, you see this incredible mosaic of all these different parts with constraints and transitions and keyframe sets and time cycles, and it's a lot to take in all at once, and you don't really know where you are. But as you start learning and seeing the overall picture, it becomes this beautiful mosaic of animation for Android. And actually, it's this wonderful prototyping experience that I've come to love and I want to share with more people. So we're going to jump into it. Just so you know, there are other talks that are better at providing where MotionLayout came from and why to start using it, and we're just gonna start with the basics and create a motion layout and go from there. So, basics first, creating our first motion scene with a motion layout file. Just throwing in in activity main a motion layout, and the very first thing ID will tell you with a little red squiggly line is that you need a layout description in order for this to be meaningful at all. Next up, you need to actually create a motion scene file for that layout description in order to refer to it. So if you look at your resource directory, you see source, resources, layout, and that's where your current layout that you're playing around with is. Well, you need to create a brand new directory called XML, and then inside of that directory, you're going to make a new file called motionscene.xml. This is where all your animation and constraints and transitions are going to go, and you're going to keep your layout file separate. So, what is actually in the motion scene file? The most stripped down, basic, bare bones version is just this. You have motion scene tag with some schemas, and that's all. There are other examples that will use a motion schema instead of app schema. So far, that seems to be up to personal preference. This is what my team uses for fluidity, working back and forth between layout files and motion scene files. So actually linking them is just as simple as saying XML/motion scene in the layout description, and it builds, and you have a white screen with nothing in it. That's boring. So we're actually going to add a child, and the first child is going to be 100 dp square, but there's no constraints yet, so even though this builds, it just goes full screen because there's no constraints. With constraint layout, this would fail to build, but motion layout is a lot more forgiving because it's trying to ascertain whether your constraints are coming from your layout file or from the motion scene file, and it does its best job. So looking back at the motion scene file, we're going to add a constraint. And once we start adding constraints, then it's like, oh, there were no constraints anywhere in any direction, but I just saw that there was a size constraint from the layout file. So this actually works. I'm going to omit schemas from now on because they're pointless for this talk. So now I actually have it constrained to the top of the start and parent, so it gets constrained that way. I'm just going to give you a little mini map so you can follow along because there's going to be a lot of XML, and I just want you to keep in mind what is actually being displayed on the screen when it's in these different constraints. The second constraint set I'm going to make, because we actually want to animate somewhere, not just have a start state, is going to be I'm going to call it the end state. And inside this end state, I'm going to give it a constraint to just the bottom of the parent. So it's just going to go from the top of the screen to the bottom. But there needs to be some input in order to cause that to happen, whether it's programmatic or user-driven. So I'm going to create a transition to describe how to move from one constraint set to the other. And I'm going to have the constraint set start point at the start constraint and the end point at the end. And I'm going to throw in an on-click gesture. There are two. I'm going to get to the other one later. But for right now, we're going to start with on-click. And I'm going to specify that the target ID for this on-click gesture is going to be the square. So you actually need to tap the square itself in order for the animation to run. The click action that we're going to start with is transition to end. And when this actually builds, it runs, and you have a little nice animation. You don't have to do any other interpolator that's done for you by default. And yeah, this is what you get out of the box in an on-click. So looking back at on-click, I'm going to want to drill into that and what the options are with that gesture. You also have transition to start, which in this scene would do absolutely nothing because you're in the start constraint in the first place. So that's not meaningful. But what you can do is have a transition to end or transition to start as one click action. This is pretty verbose, so you could actually rewrite it as toggle, and both of those do the exact same thing. You can toggle it back and forth. So that's on click mostly, and it's definitely the easier to understand of the two gestures. I'm now going to take you through on swipe, which is much more complex and much more useful for lots of cases. So the real difference is not between the constraints at all. It's just how the transitions are written and the options between them. And what it actually looks like in code is this. I'm going to focus on the differences. So it's just differences of how we're targeting and what we're targeting and what the options are of, yeah. So drilling into on swipe. The very first thing is touch anchor ID. You might think that, like the on-click gesture, that this is saying that you actually have to touch the view that you're referencing here, but that's not the case. You could actually gesture anywhere inside of the motion layout by default, and this will just refer back to the square is the thing that will guide the calculations for your gesture animation. Next up is touch anchor side bottom, and you can think of this like a little rectangle on the side of your view, or a couple calculated points that will refer that it's trying to keep the distance between that point or that side and whatever point on the screen that you're touching with. And then drag direction just implies like a horizontal or a vertical motion. So if I say bottom side drag down, then when I put my finger on the page and I move it around, it's going to try to keep the distance between my finger and that side as a calculation to guide the progress of the animation, and therefore the view looks like it's moving with my finger, and it does so very well. A couple other things that you can do with this is you could change the touch anchor side to top, and this still works just as well. Something that I just learned recently is you can use touch anchor side left and still have drag direction down, because it's looking at the bottom point of that side in order to do the calculations for the animation. This is really important whenever you have a view that moves not continuously in one direction in a view. Maybe it's not the best view to use for your touch anchor. I'll get into a specific example for how to solve for that later. Oops, sorry. Skipped a little fast. So I've been releasing on TouchUp recently, and I haven't shown you exactly what's been happening with that. So on TouchUp is an option with a bunch of different, is a field with a bunch of different options. The default one is autocomplete, and when you run this, what happens is, yeah, you're able to fling the view across the screen. It will autocomplete to whatever state is closest to it, but you can fling it as hard or as soft as you want. It will autocomplete no matter what you do. You can't just like pause it in between states. Next up is stop. So you can move this, and the second you let go, it will stop moving. This is interesting for some product use cases, but what I think most of us want is actually decelerate. Right now, this is a little strange sometimes. There are some cases where it will fling when you don't want it to fling or stop when you don't want it to stop. But this is something that I've been keeping my eye on because this is the thing that we want most, is that it can decelerate and stop before completing one or other states. Interpolation. Everybody in Android for animation usually has to make some kind of interpolator at some point. And Thankfully, in MotionLayout, this is pretty easy to use. In order to do it for any given transition, you just say motion interpolator, and then you use one of the options that's provided. Ease in, ease out is one of them. There are a lot of others. I'm going to show you what they actually look like. So these are the 3 easing transitions. So ease in is a accelerate, ease out is a decelerate, and ease in, ease out is a just accelerate, decelerate. Those are pretty simple. Then you have linear, which just moves in a straight line. Standard, which is actually a really interesting and looks better easing transition. I believe MotionLayout uses this by default. And then they have a bounce. The most practical and useful interpolator that I found out of MotionLayout is the cubic function interpolator. So you can define whatever formula you want, and I actually don't have a demo of it actually working that well, but I really recommend using this website in order to try out different formulas and functions for how you want your motion to move in terms of interpolators. So adding another state. So far, we've only had 2 states in our motion scenes, and I want to make a middle state. So it's just going to constrain it to the middle of the screen. In order to make this effective and use it, I'm actually going to make 2 transitions, one to unswipe between start and middle, and another to unswipe between middle and end. And this gives you this really powerful new effect where you can stop in the middle just by letting it autocomplete, or you can gesture straight through. This is where MotionLayout starts to show more of its power, where to do this without MotionLayout and implement it with gesture detectors and other previous tools that we had would take so much more code and so much more thought. And this is just easy now. Sub-elements. So far, I've been showing you how to write constraints at just the constraint level. And there's another way to do it is you can have different sub-elements that capture different parts of constraints in any given constraint set for a view. And what this does is it allows you to not have every constraint overwritten between different views. I'll show you a little bit more about what I mean by overwritten later when we do derive constraint sets. But to start with, I just want to go through the different sub-elements. There's layout, property set, transform, motion, and custom attribute. They more or less are just different categories of properties so that you can both keep yourself organized when you're writing code, even if you're not using the overriding portions of this, but also every single property inside of one of these sub-elements you can write on the parent constraint. The layout one is just a whole bunch of properties from ConstraintLayout. There's a ton. They work exactly as you'd expect from ConstraintLayout. Property set is super interesting. It's how you fade and change visibility of views in between different states. You can use the visibility model for that, although practically I haven't done that as much. I definitely use the alpha one, fading in, fading out views when transitioning between different scenes. Visibility mode is a flag that you can use to tell MotionLayout to stop trying to set visibility as a property, because MotionLayout is constantly setting all view properties as you're transitioning between different views. And motion progress is how you tell nested children, hey, this is my current progress and this is what your progress should be now. I'll have specific examples for those two in a bit, but custom attribute is a really interesting example or sub-element. Because it does a lot of, it has the capability to do a lot of different things. You can set custom string values for text fields, or you can change colors on the fly. You can change drawables on the fly. There are a lot of other blog posts that cover that stuff, so I'm not going to go into it. Just wanted to highlight that it's possible. But the motion sub-element, that is fairly complex and really interesting because it allows you to do things like path motion arcs. The horizontal and vertical ones, instead of allowing you just normal linear motion, suddenly give a really easy way to start having arc motion. Start horizontal just obviously creates a horizontal arc from the start to the end constraint, and same with the vertical. It's interesting that if you don't have both horizontal and vertical motion, there will be no arc, but that's kind of straightforward. Another thing that the motion subelement can do is I pointed out that motion interpolator, or interpolators can be set through the transitions motion interpolator. But another way to set interpolators is using transition easing. This allows you to set interpolators on a per view basis in different constraints. So if you want to have different views follow different interpolators, this is pretty straightforward. You just set whatever you want. If you've ever used Transition Manager and used custom interpolator and try to get Transition Manager to use the right interpolator on the right view at the right time in an animation, this is now easy. Transform. This is a super fun one because it does has the potential for some crazy effects. It basically does all the Android view transformations like translate, scale, rotate, and elevation. I'm going to show you an example of how this actually works in practice based on the original start and end constraints that I had at the beginning. And all I'm going to do is add a transform subelement. And I'm going to say that it's going to rotate 360 degrees both on the Z and X axes, XI. And what that actually looks like is this cool little floating paper animation. But I think we can make it a little bit better by using something else, keyframe sets. So keyframe sets have the ability to modify an animation in flight as you're transitioning. And in this particular one, I have just to translate a negative 64 dp and positive 64 dp at different parts of the animation. So keyframe sets are their giant topic all on their own, and I want to spend a little bit of time on them. So you can have up to 100 different keyframes for any given view in a transition. They let you specify a change at a point in time during a transition. And it more or less works like this, where you, for any given view, you can specify keyframes. MotionLayout's progress goes from 0 to 1 as a floating point. Keyframes go from 0 to 100, and they just map accordingly. So 75, the 75th keyframe, it maps to 0.75 progress. You can also have different keyframes for different views. You don't need to have a keyframe for every single view at every single time. So you could have 2 different views, moving, translating, oscillating, rotating at different points in your animation. And it just runs through your keyframes just as the normal animation does, just modifies paths or other properties. So back to the example that I had with that square floating down, what was happening was as I moved through the animation, in the timeline of the animation, you would see it move to the 33rd keyframe, and at that point, it would have translated in the X direction, negative 64 dp, and then at 66th keyframe, it would have translated to the right, 64 dp. There's something interesting about that. So I just wanted to highlight how this actually moves. When you move from the 33rd to the 66th keyframe, I don't have to say translate X 128 dp. I just have to tell MotionLayout, hey, this is the modification to the original path that I want. I don't have to have keyframes built on other keyframes. Everything is declarative. This is super powerful, and it makes building complex animations with specific timing very straightforward. There are a bunch of other keyframe attributes under keyframe set. So there's keyframe or key position, which more or less transforms the position or path that you're actually acting on. And then there's key cycle and key time cycle. I don't have time to go into those. They're super complex and really fun. You can do really amazing oscillating animations with them, but there are other talks that do a better job going into them. I want to have time for practical examples. So who here has used swipe item helper in a RecyclerView? Cool. Who here has had pain doing that? Pretty much the same people. Good. So you're going to like this. So I have this RecyclerView, and what I'm going to do is give it a view holder, and the layout for that view holder is just email item, which happens to be a motion layout. So every single view holder will be a motion layout. And what I want to do is just have an on-swipe gesture for each of these view holders. Looking at the actual motion scene that I wrote for this, I was just like, basically did the start and end constraints just like for the other little square animation. And I just specified, okay, the on-swipe transition, oh geez, that was broken. That didn't work. Basically, I wanted to show you a broken animation, and that was a broken animation, but not the one I wanted to show you. Basically, if you try to do this as I had set it up, it more or less would break and not work. It would go between progress 0 and progress 1 instantaneously without any transition whatsoever. So in order to fix this, I'm going to drill into the actual layout. I'm going to color this black to make it a little bit easier to see what I'm doing here. There's no change in horizontal position of any side in the foreground view because it is match parent. MotionLayout can't calculate any kind of differential distance between the sides of the motion layout as the view holder and the actual element inside of it. So it can't move, so it can't translate, so it just says, I don't know what to do. Therefore, it can't interpolate. So how do we fix this? One way that I thought of was you can create an empty view that constrains itself to the side of the parent, like that. And then you can use, rearrange the constraints of the view holder, the foreground, and all of its internal views to move in constraints that way. Another way that John Hofford recently showed me last night was you could just, instead of doing that with an on-swipe to get this effect, you could actually just do the same thing, but not have an empty view and just say on-swipe without any touch anchor. This is possible, and it works, and the example runs just as it did in the other rendering. Next up is collapsing toolbars. Lots of people use coordinator layout for collapsing toolbars, and generally they're awful because trying to customize them in any way to have things move inside the top of the collapsing toolbar is really annoying. So what we're going to do is use MotionLayout instead, and at the end of it, it's going to look like this. There's nothing inside the toolbar yet. We're going to do that in another example later. Again, just like a simple start and end constraint with an on-swipe. And what I'm actually wanted to point out is how the constraints for start and actually work in this. So the header itself just has a fixed height, and RecyclerView has normal constraints. But in the end constraint, I don't have any constraint for the RecyclerView. And the reason for that is this little thing called derive constraints from. Because the RecyclerView's constraints don't need to change in between these two different constraint sets, I don't need to redefine it as long as I have this flag. It's going to try to copy over as many properties as it can as long as I don't specify any constraint properties for that specific view. this is where sub-elements would come in handy if you didn't want to copy over, or rather override everything from a derived constraint. Next up is nested motion layout. So you actually have something that looks usable in the header. So we're going to make that. Instead of the previous example with a view for the header layout, I'm actually going to make it a motion layout. So motion layout inside of motion layout. And the header scene for that is interesting because I have a choice to make now of how I'm going to scale the text inside the header. And so when I look into this, one option maybe is using custom attributes with text size and custom floating points. But maybe another option is using the transform sub-element. Well, which one works better? Doing some different testing, you can see that the text size with custom attribute gets flaky because when you try to do change font size of a text view, it needs to recalculate its own wrap content, and then motion layout can't keep up with it and it dies like that. This is problematic, not specific to motion layout. Like if anyone's used or dealt with trying to resize text in an animation as it's moving, it just doesn't work. So highly recommend scale. That's what we use in production. So that's taken care of. Next up is actually doing, telling the child, hey, you should actually animate the header. So the way we do that is in the start constraint, we say motion progress 0. So the parent is at progress 0 in its start constraint, and it's telling it, the child header, hey, your progress should be set to 0, or animate or interpolate to 0 when I'm directing you towards this state. And then in the end constraint, do the same exact thing except motion progress 1, and then you are 1-for-1 values between the parent and the child. And that just works. Changing text in motion layout is really interesting. I've run into lots of text things that my product and design people want me to do. And as you can see here, it's kind of weird where I'm doing the scaling thing that I just said was the best way to solve scaling text in a collapsing layout header, but it's kind of failing because it goes off screen. What's actually happening is because I'm doing wrap content on that text view, it is not keeping the same exact pivot point. So what I can do to solve for this, because motion layout, when it builds the scene originally, it captures view properties and doesn't understand that a child's internal content is changing, especially text, is I can change this to match parent with, and then the text view's size essentially stays the same no matter what text is actually changing. As a bonus, you can actually delete the constraints when a view is matching parent in the direction that you're matching parent. So I can get rid of start and end. I just constantly, whenever I'm doing motion layout work, I'm always trying to find ways to have less and less XML. Visibility. So this is the visibility ignore thing I mentioned I would get back to at some point. In this example, I actually have a runnable that's running every second and trying to set the visibility of that weird little circle in the header, and it is failing because motion layout is actually constantly saying, make this visible, make this visible. In order to get around that and actually have it be toggleable, you need to say visibility mode ignore. And then there's no problem updating its visibility. In practice, it's sometimes weird when you have a view that starts as visible gone. It's something that we've been trying to work through. And then the two different values for this are just ignore and normal. Normal is the default, and it's the default for all views in all constraints. It's important to set visibility mode ignore in both your start and end constraint in whatever transition that you're talking about or working with. changing constraints programmatically. This is the fun part where we go into Kotlin a little bit. Because MotionLayout is just an extension of ConstraintLayout, and MotionLayout kind of started because a lot of people were using ConstraintLayout to do weird, fun animations. There's a similar API for being able to programmatically change a constraint set. And what you do is you just say update state, set the transition, which will also internally reset the progress of that, and then you can programmatically kick off a transition to end. And the way that this came up and I worked through how to work it out was this example where I had a photo grid and I was trying to not have 10 different constraint sets to specify how each view should be zoomed in to take the full width and height of the available view. So programmatically, just set some constraints. Can also set the elevation with the constraint set. And then I say update state. And then in my actual motion scene file, it's super simple. I have two constraints, grid and zoomed in. And this saves me a lot of time and effort and also maintenance, because handwriting lots and lots of constraint sets endlessly would be really bad. Next up is RecyclerView and MotionLayout placeholder. So in the previous thing, I was doing programmatic stuff in order to change constraint sets. There's no reason that you can't do that with view holders and the view positions. So calculate their position and size and whatever. Update the placeholder view within a starting constraint set. And then I show it the hidden motion layout that has the placeholder. And this is what it looks like. This was one of my prototypes when I was first building this. And you can tap things. They jump out into a placeholder inside of a motion layout that is hidden on top of the recycler view. And it looks nice and smooth. Auto transitions, they are super fun. I built this thing in order to try out as many things as I could throw into it as possible with path motion arcs and image filter views. And the idea behind this is that there are about 8 different constraints where I'm just saying auto transition, animate to end, and every single transition in the file has that property set on it, and therefore I can get this fun looping mechanic. I would advise, like, if you're having any issues with auto transitions, make sure that your durations with them are reasonably long and that you're not trying to run them so fast that they can't run at all. But they work really well. And also you can programmatically change transitions on the fly. This was an example. I saw Nick Butcher's talk about how to do reentrant and interruptible animations, and basically what I did in that little demo was I had 4 buttons that I could constantly try to reset the current destination and also a stopping point as I was resetting the destination, so it could look like it was actually slowing down before it reset its direction. So that's super possible. I used to have to do this with reflection. I think in beta 2, it's part of the public API now. I'm not completely sure about that. Also, I haven't found a practical use for doing this stuff. It's just super fun. I was having a good time. But maybe you will. Maybe you'll make a fun game out of this. Debugging is very practical. It's always asking what state am I in whenever I'm talking with my team about motion layout. So there are 3 properties, start state, current state, and end state, that you can get from motion layout. They're extremely useful for debugging. Another thing that you can use for debugging is show paths and motion debug all. It'll give this nice little progress output at the bottom of the screen. If you use the motion sub element with draw path, I didn't mention this earlier as a sub element thing, but this is super useful for figuring out what the path for an individual view is inside of a motion scene if you don't want to render the paths for every single thing in your motion layout, if you had 30 or 500 different views. Debugging, there's some fun extensions that I've been making for whether something needs a transition and figuring out, oh, -1 as current state actually means moving. Okay, are we at the destination, yes or no? And then I can use this to figure out where to move next or whether I need to activate a transition. Res name is just a nice little extension for myself for logging purposes as we're debugging. Just uses context resources, get resource entry name. You can reuse this on normal resources as well, and we do now. And then when you use set transition listeners, as often as we do, we end up making a bunch of different extension functions, and this is just one of them. I will note that allows transition. If you see this in beta 1 and earlier examples from other talks, this is actually removed in beta 2. There are some limitations and problems that can't be solved with derived constraints, and sometimes you have to handwrite them, but creating a large number is very infeasible. One example is this fun little sliding tile puzzle. It has n factorial divided by 2 states, depending on the size of the board. And then if each requires a handwritten state, and I want to write a bigger puzzle, this one has 12 states I had to write, and they were fun, but I don't want to write a 3x3 board ever, because that would be 180,000 states. Thankfully, in the future, this is a demo of the, this is a limitation of the current model. John says that they're going to work on this, and then I can make a 3x3 board. Other practical examples. Swiping items with a collapsing toolbar, and also having them automatically close on their own is super simple and straightforward. Just have to have an either RxJava or coroutine thing monitoring those events and saying animate close. We've created these really fun progress indicators in our app. Stuff like this that's super simple, where it's just I have 2 states, start and end, and all I'm doing is creating a bunch of drawables. Creating this with draw on canvas would be painful and would take way too long to get it right on every device ever. And in MotionLayout, it's just straightforward and simple. Another thing that you can do is get into charting with either progress bar animations or other stuff. Generally, it's just whatever you want to animate using custom attribute sub-element animations. Just go nuts and have fun. More practical, though, is like a tab layout with many nested scroll views. The interesting thing about this example is that in all my other ones, MotionLayout is usually the one who's driving other views and telling them what to do. In this example, the nested scroll views in each of the children is actually telling MotionLayout, hey, I want you to set your progress to this right now. And MotionLayout accepts it. So it can go in either direction. So, in summary, reduces context switching. It makes some hard animations much easier, and it allows us to make animations reentrant, continuous, and smooth. If you watch Nick Butcher's talk about motional intelligence, it's definitely been a big inspiration for some of the animations that we've been making. Some challenges, they're still remaining. It's still in beta. Lack of official learning materials, though, is actually done because there's an awesome, amazing code lab that's taught me stuff recently. And the debugging part, now it's just so much easier with Motion Editor. So I wanted to show you what we actually have put in production with Hinge. So this video, if it plays, because I just added this like on stage about 5 minutes ago, this is our onboarding flow, and we have MotionLayout as the progress indicator at the top of the screen up there. And as it moves from screen to screen, did it just freeze? Oh God. Live demo. Please play. Oh God. This one is more fun. It's our actual app and how things get used. So we're just nexting and undoing different profiles to go back and forth between. Everything is nested motion layouts. This is a really fun one where we do image pixel matrix transformation while we're doing motion layout entrances into different transformations. And this is so much easier than working with shared elements. Thank you so much for watching my talk. Any questions? That's it.